Dr. Vivek Desai, who is a well-known name in the as a founder director of HASMAC and also in planning and management of hospitals in India and GCC countries. And he has also been advisor to World Bank, UNICEF, WHO, Ministry of Health, Family Welfare, etc. He has been invited in the prestigious forums of national and international to deliver his views on the hospital design and thing. For his untiring efforts, Udyog Ratan Award has been instituted to him by Economic Studies, was selected as Leader of Tomorrow by Economic Times. Now he will be talking to us in the panel on hospital designs and energy conservation. Dr. Vivek Desai to open the session with the design and his input on
that. Thank you, Dr. Nagendra. And it was a pleasure hearing to both Dr. Mohan Chellappa and of course Dr. Pawan Kapoor, who has been my mentor as well. Now I'm going to talk and stick more to about designing of hospitals, leaving the other topics to the other panelists. So I think the first and foremost, thing that one needs to do, I have a presentation, if Kao can put it on the screen, it will be nice. So the first fundamental, issue that we have to deal with design is that we are generally more, focused on the glamour of the building, and you can see behind me, number of pictures which are there. But important thing to understand is the form of a hospital should follow the function, and it should not be the other way around. So you should not design buildings and then try to fit in hospitals, but you must have hospital functions decided first, so space programming, what comes where, stack program, all of that, needs to be done first, and then that form should follow function. So the way you create a hospital mass should follow the function, that the hospital is supposed to render. You can see on the left-hand side number of ways that you can design a hospital. So the form generally needs to follow the function. Let's go to the next slide. Which brings us to the topic of, what kind of a grid matrix. So grid matrix is the column layout of any hospital building. Okay. So grid generally would be, say, in Western countries, they work with longer grids, say 9 meter by 9 meter. In India, we are more used to work with 7.5 to 8 meter grids. The red dots that you see is actually the grid. And this grid cannot be changed once you frame it, right? So you would have different type of hospitals going for different type of grids. The medical college kind of projects, what Dr. Pawan Kapoor was mentioning, probably will work with smaller grids, 6.5 to 7, whereas a super specialty, bigger hospitals would work with a 9 meter grid, which is the thing. So this typology will get fixed once. Larger the grid, more easier to accommodate functions like operation theaters, cancer facilities, cath labs, MRIs, larger ICU units. Larger the grid, more flexible will be the hospital. Let's come to the other point, which is now to do with what will happen to hospital designing post the COVID pandemic, So we would need, because of this physical distancing, we need spacious waiting areas, so you would need longer distances. So waiting areas will go up, area per bed will increase. Just to give you a, as compared to the United States, where we have 2,000, 2,500 square feet per bed, Indian hospitals work with 700 to 1,000 square feet per bed, So, but there is going to be an incremental in that. Pre-engineered buildings, I think will come up now, because one needs to, this has taught us that we need to create hospital infrastructure very fast, right? So a pre-engineered building allows you to do that, okay? So you just need to erect the hospital. It might take in 10 days to 50 days to 100 days, you can make hospitals nowadays. So we should look for those with convertible air conditioning systems, as Dr. Pawan Kapoor was mentioning, the positive becoming to negative. And in urgent cases where you don't have such kind of flexibility in your system, at least have a mechanism to exhaust the air out so that you create a negative pressure within the enclosure in which you have. technology usage for low touch or no touch, that kind of concepts is going to come up now. So you don't open a door using a doorknob, but you open by your feet, like that. Partition consult rooms, so you have a screen between the doctor and the patient nowadays. Robo delivered hospitality, which Dr. Monchalaka was also mentioning, is going to come in use more and more. Many things probably will get delivered through pneumatic chute systems. Hands-free wash basin, urinals, toilet seats will also be of different kind, which can be also at times with disposables. You would need to have all that you see around you will need to be sanitizable. Okay, so when I'm saying that, you can imagine a sofa or a carpet or other things will slowly go out of the work, and you will need something which can be easily be sanitizable. Germicidal coatings, for coronavirus, for high touch points like the door knobs, the toilet door knobs, intensive care unit where you use a lot of other things, lift buttons, which will be there. So you would need a germicidal kind of a thing. So we used to earlier recommend copper, as a metal which had a microcidal kind of property. So something like that probably will have to be thought of. There will be a very low use of curtain and cloth tapestry because you cannot wash them, cannot sanitize them that very often. So that probably will go out, and whatever is washable and sanitizable will, be more and more used. One lesson that we have learned is, to bring oxygen to the point of patient care, and this is, we have found that as almost all countries globally were not prepared for something like this, right? So you would now probably have parking lots, big halls, everywhere you would probably need to reach oxygen, connectivity at least, so that as and when such kind of a emergency, comes in, you are able to supply the oxygen. Mobile hospital modules as and when required basis. Okay, so one of the interesting things that India tried was converting railway coaches into COVID kind of a ward, so that instead of bringing the patient to the hospital, you are able to take the hospital to where it is required, because India faces the problem of not enough healthcare infrastructure in hinterland India. Tier 3, tier 4 or rural areas, we do not have that kind of infrastructure. So this is something that probably one can do. We are currently in talks also with the Indian Army for creating such quick hospitals in Ladakh, for the reasons of the impending tension at the border. So those kinds of hospitals which can be very quickly made can be taken to intended kind of infrastructure. Then hospitals probably in future would also have to be in sort of designed in a manner that you can very quickly, whenever required, use one section of the hospital for infective cases and the other, for non-COVID. Now that was the biggest stumbling block with private hospitals, especially in city like Bombay, where I come from, where there were vertical structures unable to convert a hospital into COVID, non-COVID. So you would need a winged kind of a design where you are able to segregate, such infectious cases from the non-infectious ones. So those kinds of building blocks would probably in future design will need to be thought of. Thermograph at the entry at the public, so that you can identify a patient immediately without having to test, everyone. Your thermograph will identify, and you can then trace, that kind of a patient. Energy efficiency. I think one of the most hospitals are generally guzzlers of electricity because we work 24 hours, 365 days non-stop. Even in an operation theater, we need to maintain the positive pressure of the operation theaters, throughout. So it's not like just once you are finished the, surgery, you can to shut off the AC. No, it's not like that. Can we just roll on the slides, please? So we need, and why do we need to be energy efficient? Because by using those methods, you are able to cut down the energy usage by 24 to 50%. And that's a huge kind of a cutback. So if you look at any hospital's balance sheet, you will find about 3 to 5% of the expense, at least in India, towards energy. So that's a big amount, which could be saved if you are energy efficient. Water usage goes down by almost 40%. Solid waste usage, goes down by almost about 70%. And importantly, Air conditioning, and I think Chris probably would be the right person to talk more about it. But air conditioning takes away almost about 40 to 50% of this energy cost. So if you are careful with the way you design your air conditioning systems, I think there's a lot of saving that will happen around that. Lighting contributes almost about 21%, and then the rest goes to the medical equipment where you can't save because you have to use the equipment. So if you concentrate on air conditioning systems and the lighting, I think there is a big energy saving that one can do. So I would end with the last slide saying that growth will be inevitable, right? And resources are always going to be finite. So to that extent, technology will always improvise, and design will have to work in tandem, with the technology, and compact, well-planned, value for money hospitals is what countries like India at least would need, not the luxury kind of hospitals. And we need to probably follow the diktat that less is more kind of a diktat when you design hospitals. So I think with this I will end the talk and we'll wait for the others and then for the questions. Thank you, Dr. Swami.
Thank you, Vivek.